Hi, everybody. Thanks for joining, taking the time today. Today's topic is modernizing hybrid cloud backup using AWS. I'm Chandra Reddy. I'm the AWS Storage and Data Lake Specialist. And with me, I have my colleagues and friends, Alan Henderson. He's the AWS Storage Solution Architect Specialist, and Tom Husak, who is the AWS Storage Sales Specialist. And as I go through today's topics, here's the agenda that I built together. It's a 45-minute session. In the next 30 minutes, I will cover all these topics. And if you have any questions as we go along, please post your questions in the chat window there, and Alan and Tom will be able to help you. And if there are any questions that need to wait till the end, we will spend approximately 10 to 15 minutes towards the end going through some of those questions as well. But please don't hesitate to ask your questions in the chat window as we move along. All right, so let's move on. So some of the top backup vendors, here's the list, right? Commvault, Cohesity, Dell EMC, IBM, Rubrik, Veeam, and Veritas. They're all in the top magic quadrant from Gartner. And chances are high that you probably are using one or more of these products, right? So today's session is more about how can you leverage your existing product or any of these products along with AWS and modernize your backup architecture. Every year, thousands of petabytes have been backed up from corporate data centers to AWS cloud using any of these backup products. So there is a tremendous amount of faith that customers have shown in backing up their mission-critical data into AWS, storing it securely in many different storage tiers that I will cover in the next few minutes. To understand why AWS has been such a popular destination cloud for backups, we need to understand, let's start first with what are the typical challenges with the legacy architecture, right? So the first one that comes to everybody's mind is tape backups, right? So typically, customers who leverage tapes, they protect their workloads on premises with a backup software or an appliance and have a local backup copy. And once they have a local backup copy, they create a copy to tape and then ship the tapes offsite. They might have another copy on disk as well. The challenges with this tape is, number one, what just got exposed last year, unfortunately, because of COVID, was access to data center. There was a big constraint in just getting into the data center because of the challenges last year. And that surfaced up major challenges because now the tapes could not be exported. Beyond that, when you try to restore from tapes, in general, there is very low confidence, and there have been sufficient surveys out there which demonstrates this challenge. And when you are able to access the tape and when you are able to do the restores, it takes a long time to do the restores, assuming you have the right tapes at the first place. A very high operational burden in managing all of this, and of course, expensive tape library costs as well. So many of the customers have done is they have eliminated tapes, right? And instead of that, they actually took the second approach, which is disk to disk to disk, which is back up to a local storage, and then take the data and move it to the second location in a offsite data center or a co-location. And that's where you have, again, your backup software running, and you have another storage piece there. Now think about it. What do you need in the second offsite data center? You need to run this backup software in a compute, right? So you have the compute expense there, and you have to manage it. Of course, chances are high that you might be running that in a hypervisor. You need storage, definitely. You need switches and firewalls. You need bandwidth. You need space and power. All of this add up, not only in terms of hardware costs, but also in terms of operational burden in managing all of that. Patching all of this infrastructure is an operational burden. Capacity management. Many organizations acquire companies or add new workloads. And as you add new workloads, you need to go back to your spreadsheets to determine, is the current storage good enough, or do we need more capacity? Can the media servers or backup servers handle this traffic in the second data center? All of that capacity management is extremely complex. Underutilization. So what do you do when you need 10 more terabytes? You can't just get 10 terabytes. Chances are you're going to add 50 or 60 terabytes. And a lot of that goes underutilized, right? Expensive hardware refresh, especially if you're using some of those expensive deduplication appliances in the offsite data center, the hardware refresh can become expensive. and of course, operational burden in managing all of this infrastructure, which does not necessarily add to your company's top line revenue. There's no direct contribution there. So what if you could modernize your backup architecture so that you can solve all these challenges? And that's what we will talk about in the next few slides. So if you're this on the left-hand side is your production data center, those are your workloads. You can continue to leverage your existing backup software or pick any of the top backup softwares that you mentioned. All of them have almost an AWS first strategy in terms of anytime they want to come up with a new capability, they first integrate with AWS and test it out and roll it out, right? So pretty much they have deep integration with AWS. So continue to have a local backup copy. All you need to do is modify your backup policies here, and pretty much everybody supports this, wherein the backup will be deduplicated, compressed, encrypted, and then the data is stored in Amazon S3, which is a scale-out object storage with almost infinite capacity. So instead of storing the backups in your second data center, the idea is to store the backups in Amazon S3. And this storage just grows and shrinks on demand. If you add more workloads, you don't have to do anything on the right-hand side. Your backup software will continue to write, and the amount of storage will increase. If you take out some of the workloads or you reduce the retention, as an example, you don't need as much storage on the right-hand side. You don't have to do anything. The backup software will automatically delete the backups, and the storage consumption will be reduced, and you don't have to pay for that extra storage. So, of course, you also have the option. Some of our customers, they need to have data in their own data centers. So for those customers, in their offsite data center, we also offer S3 on Outposts. But I would say 99% of our customers are primarily in Amazon S3 in our AWS cloud instead of S3 on Outposts. The benefits of this architecture is almost every one of the backup products that I mentioned, they have an AWS first strategy. They integrate deeply with AWS. You get almost infinite storage capacity in AWS. So you never have to worry about storage capacity management. There is zero operational burden in managing the storage in AWS. It's a managed service, right? It's an API call, and it grows and shrinks and consumes. And last but not the least, you pay per use, right? So there is no hardware refresh or massive capital layout. It's all pay per use. So this was at a very high level, the architecture and the benefits. So let's dive a little bit more deeper. Is S3 the only storage? No, they actually have a family of products behind S3. And it might get a little bit complex. I've seen lots of customer conversations where they ask, should I use S3 or should I use S3 IA or Glacier? How do I use this? So that's where we can optimize your costs in Amazon S3 by leveraging multiple storage tiers. So the way I have organized this slide is I'm going to go through each and every requirement or use case that I typically see or customers ask. And I will explain what is the right solution or storage tier and what are the cost benefits, right? So let's take the first one, which is, let's assume that a customer you have lots and lots of restores that need to happen from an offsite location. Remember, you have a local copy in your data center, and 95% of the restores will happen most likely from your local backup copy. But for whatever reason, you have a scenario where you need to do lots and lots of restores from your offsite copy, then that's where you will restore from Amazon S3. Since you will be restoring lots of stuff from Amazon S3, I would recommend Amazon S3 storage tier, S3 standard, and that costs approximately $23 per terabyte a month. Now, remember, the pricing varies by volume and regions. This is a ballpark estimates, and TIB indicates 1,000 gigabytes instead of the traditional conventional 1024, just to keep the math simple, okay? So my idea, the goal here is to give you an approximate number, not an exact number. All right, so as I said, 95% of the restores happen from on-premises backups. Very few restores have to happen from the Amazon S3 storage tier. So if that's the case, then, and if you have 30-day retention, which means you will not delete your backups in 30 days, then I would recommend leverage Amazon S3 standard infrequently accessed storage. And that almost reduces your storage cost by half. As you can see here, $12.50 per terabyte TIB month, right? So few restores, 30-day retention, use Amazon S3 IA. And remember, S3 and S3 IA is not like the traditional storage in your single data center. This data is actually stored in 3 availability zones in a single region. And each availability zone, in fact, depending on the region, it may have one or more data centers, right? So it's really, really highly durable. 11 nines of durability is what the storage tiers can offer. Now, 30-day retention, few restores, and if you think that, you know what, storing my backups in 3 availability zones is an overkill, at least for my not so important workload backups, then maybe you could consider Amazon S3 one zone IA. Idea is the data is stored only in one zone, but you are not sacrificing your durability. You still get 11 nines of durability, right? And the benefit is that the cost reduces further, $10 per terabyte month. If you have a retention of at least 3 months, the backup retention of at least 3 months, you could store the backups in Amazon S3 Glacier, which reduces the cost further to $4 per terabyte month. Obviously, the access times from Glacier is going to be longer as compared to S3 and S3 IA and S3 one zone IA, the first 3 storage tiers, which is in milliseconds. This could be in minutes to hours, depending on how you restore the data. If you have 6+ months of retention, and many of our customers have like multi-year retention, Amazon S3 Glacier Deep Archive would be the best choice. It's less than $1 per terabyte month, right? And many customers actually use a combination of these. So to give you an example, daily backups might go in Amazon S3 Standard IA, and monthly backups might be returned directly to either Glacier or Glacier Deep Archive. Another example is low priority workloads could be directly returned to Glacier or Glacier Deep Archive, not even storing in S3 or S3 IA. Talk to your backup vendor if they have the capabilities to directly back up from on-premises into Glacier or Glacier Deep Archive. Most of them do, just to make sure, have a chat with them. So these are the various cost optimization techniques, going down all the way from $23 per terabyte month to just under $1 per terabyte month, depending on the use case and your requirements. Okay. And please don't forget to ask your questions in the chat window. Alan and Tom will be helping you out. And for some of the questions which requires more elaborate conversations, we can always use the last 10 minutes. All right, so moving on to security. Ransomware, has been in the news. Lots and lots of enterprises want that peace of mind that there is a proactive approach and there is a reactive approach. Proactively, you want to not get your data infected with ransomware, right? So that's the best approach. That's the first line of defense. However, you also want a reactive approach where what if, in spite of taking all the precautions, your data still gets infected with ransomware, you need the ability to go back in time and recover from your backups. And that's why backup is absolutely important in the context of ransomware, so that you can go back in time before the infection happened and you can recover rapidly. Now, having said that, now the focus shifts to backup software and the backup media. How do you make sure that the backups are not compromised? And just like any security principle, you need to devise a strategy of multiple layers of security. And so the first one is some of the backup products have actually anomaly detection. So as an example, if a ransomware infection encrypts some of the files, the next incremental backup might see a spike. That's just a very, very simple example. Some of the backup products actually have much more sophisticated analysis. And talk to your backup vendor and ask them if they have this anomaly detection. If they have it, the backup software will report it, and you might be able to take action. The second thing is role-based access control. Pretty much every backup product today has role-based access control. So as an example, Alan might be the administrator. He should be able to do everything. Chandra, on the other hand, is a restore operator. He should be able to do only restores. So make sure that role-based access control is being used. Not every user should get access to, for example, modify backup retentions, right? So this way, you protect yourself against any disgruntled employees or somebody making a mistake by any chance. Another important aspect is log actions from various users. Almost all of the backup products have the ability to create an audit log, wherein if Chandra logs into the backup software, it actually puts a log message that Chandra logged in. Having such capabilities deters somebody with malicious intent to log into backup software and start deleting the backups, right? So that's an important capability that you should ask your backup vendor. Another important aspect is retention lock at backup application layer. Some of the backup products actually allow you to put a soft retention lock at the backup layer so that Not even Alan, who is an administrator of this backup software, can go back and change the retention or delete the backups. That's a wonderful first line of defense at a software layer. Now, let us assume that you took all these precautions. What if somebody goes into the storage layer and starts hacking the backups? So that's where, ask your backup vendor to see, or the storage vendor to see if there is a retention lock on your on-premises storage. Now, so far, all of these preventive mechanisms are in your production data center. Now, the next thing is the backups are stored in S3 or Glacier Deep Archive. You want immutability there as well. You want air gap, and that's exactly what AWS offers. You can not only encrypt the data, but of course, you can also make the backups immutable, which is a retention lock. And many of the backup products have actually integrated with S3 object lock. So ask your backup vendor if they have done so. Most of them have done. So that way, the backups stay locked and nobody can start deleting the backups. And last but not the least, you want the peace of mind that you can actually recover your applications, right? I want us to think about ransomware actually as a disaster event, right? This should be taken seriously. And if we treat this as a disaster, automatically the next logical step is doing more and more DR tests, even once a week, and automate a script which will read the backups and recover into a protected virtual private network as Amazon native EC2 instances. Almost all the backup products today can recover an on-premises physical server or a VMware virtual machine as a native EC2 instance. So this would be like the final step to make sure that last night's backups are actually fine. Randomly pick up server and recover it to a native EC2 instance. And you could automate this via scripts, via APIs. So that's what I wanted to share around ransomware encryption. But beyond that, there is another level of defense. Encrypt everything. Some of the backup products support agent-based encryption, which means even in your LAN network, data is encrypted. Some backup products support encryption at your media server or backup software. You can encrypt at storage layer, encryption at rest, and of course, encryption in transit, either using VPN tunnels or the backup software has already encrypted and sending it to S3. And of course, you can always turn on encryption at rest with Amazon S3 and also actually key management capabilities that AWS has to offer. So that's about encryption. The next one is networking options. So in the previous slide, you saw that the backups are being transported over the wire from on-premises into AWS. So what are the networking options? There are many networking options. One is you can go over the public internet and make sure that you enable encryption in the backup software layer so that all data is always encrypted before it leaves your network. And of course, the second approach when you're sending data over public internet is to use a VPN. As you can see here, I have put a dollar number here. Obviously, using a VPN will be a little bit more expensive than sending it over the public internet using the backup software encryption, which practically most of the backup products generally give it for free. Of course, you can always use a dedicated network, and this is almost dictated by how much data do you have to send, right? Typically, more than 10 terabytes per day after dedup and compression, you pretty much need a dedicated network so that you can get low latency, predictable throughput from your data center into AWS. Now, even though you have a dedicated network, you can still choose to encrypt the data at the backup software layer, or you can use a VPN. And as you can see here, the cost of all these networking choices increase as you go from public internet and you start using VPN, or you use a dedicated network and you use VPN in a dedicated network. So those are the many networking options. I do actually have deep dive reference architectures that I would love to cover today. If you want to go through them towards the end of today's discussion, I will definitely find some time to go through them. Just put a +1 in your chat window if you want to learn in depth about all these 4 architectures that I just mentioned, because networking is extremely important, and security is job 1 here at Amazon. It's the most important thing for us. So please put a +1 if you want to learn more today on those networking options. Let's talk about recoveries. The whole purpose of doing the backups was you want to access the data when you need it very, very quickly. So there are multiple choices on how you want to do recoveries, right? So assume that the backups were already done, stored in S3. So the first thing that could happen is your backup server. You spin up backup server in an Amazon EC2 instance as an example, and this backup server will rehydrate. Remember, the data was deduped and compressed, so it will have to read from S3, undedupe or rehydrate the data. That's why the large recovery time. And most of the backup products today can recover them as a native EC2 instances. So you have on-premises physical servers or VMware VMs or Hyper-V VMs, any other hypervisor. Typically, the backup products have the capability to recover and as native EC2 instances. The next part is some of them can also recover as actually VMware virtual machines in AWS. So that's another important aspect, right? You not only recover them as EC2 instances, but you could also recover them as native VMware virtual machine if you want to recover to VMware Cloud on AWS. Ask your backup vendor if they support both of them or one of them. So that's like the most primitive way to recover rapidly from your backups that are already stored in S3. Of course, you could always restore back to your data center. This is more about a disaster recovery scenario where you want to recover. Many customers actually have started using their backups to recover into their test and dev environments as well. So that's another important use case. What are the benefits of this approach? Low cost, right? I mean, 24/7, you're just paying for S3 storage costs. You're paying for this compute only at the time of recovery. So your costs are low. You don't have to maintain a museum of infrastructure in your second data center. And hence, it eliminates your hardware refresh costs. It also allows you to detect corruptions or infections sooner with frequent recoveries, like once a week, do the recoveries into a secure VPC. Make sure it's not infected with anything, right? So the fact that you can actually recover the entire application stack gives you the peace of mind that, yep, my data is good. The disadvantages of this approach is obviously large RTO because you have to actually undedupe and rehydrate the data. And then, of course, large RPO because the chances are you're backing up once a day. What if you can improve on the RTO? And most backup products actually allow you to do that. So how do you recover rapidly in AWS? So talk to your backup product if they have this specific capability that I'm going to talk about. Most of them have today. As and when every day when they're doing incremental backups and deduping and storing it in Amazon S3, they also have the capability to actually rehydrate the data from the S3 and store it as an EBS snapshot. It's basically a snapshot technology that they can leverage and store. And remember, in AWS, snapshots are stored in S3, and hence the costs are lower. So you're not consuming elastic block storage, which starts at $100 per terabyte month, right? Whereas the snapshots cost only $50 per terabyte month. So low cost, yet faster recovery because of the fact that the backup software has the intelligence to convert their backups into EBS snapshots. So your backups stay in place. They are not tampering your backups in S3. In addition to that, what they're doing is they have this added ability to store those backups as native EBS snapshots. The benefit is whenever you want to access the data, recover the machine, it's already an EBS snapshot. So it's very, very fast to recover from an EBS snapshot, almost within minutes. So you can spin up an on-premises virtual machine as a native EC2 instance within minutes if your backup product has this capability. So ask your backup product if they have this capability of storing the backups as an EBS snapshot. So the benefits of this is, of course, lower cost because 24/7, you're just paying for S3 costs and this EBS snapshot costs. You're not paying for EBS or EC2 instances. So that keeps the cost low. And of course, it's low RTO because you can recover rapidly from EBS snapshots. RPO is still large, right? I mean, some vendors do claim that they can do almost an hourly backup. So if that's good enough, 1 hour RPO, this is great solution. However, if you want really low RTO and RPO of minutes, then here is a technology from AWS called Cloud Endure. Now remember, I'm not suggesting replace your backup with Cloud Endure. This is an augment solution. So keep your backups. You need that to go back in time and recover. You need that for multi-year retention as an example. Use this technology that I'm going to talk about only when you need low RPO for some of your mission critical workloads on top of your backups. So install Cloud Endure agents at a very high level. I'm going to talk through this. So this is an asynchronous replication technology which keeps track of change blocks on your physical servers, virtual machines, VMware, Hyper-V, everything. And even if you have some machines in, let's say, Azure or GCP, for example, we can even replicate machines from those clouds into AWS. So what it does is it keeps track of change blocks and asynchronously replicates into Amazon. And since this is a native AWS services, all the data is stored in this, let's call it as a staging area, where lightweight replication servers receive the data and then stores them as in EBS volumes. And they also actually store it as EBS snapshots. So continuous replication is happening, and then every now and then it takes EBS snapshots. And then when at the time of recovery, so this orange box comes up in your VPC, virtual private cloud, only when you need it on demand. So what happens then is that you recover from these EBS snapshots, and recovering from EBS snapshots is pretty fast. So that's how you reduce RTO, and RPO is reduced because of this continuous keeping track of change blocks continuously and replicating to the AWS side. So low RTO and RPO. The disadvantage is relatively higher cost as compared to the backup software. However, this is still lower than managing your on-premises DR because all this compute infrastructure is leveraged on demand at the time of recovery. Okay, so 24/7, you're only paying for the staging area costs. That's it. All right, so this is great. We talked about the various recovery approaches. But there is a bootstrap mechanism. To recover, you need the backup catalog. So how do you get the backup catalog to AWS? There are two options. You can either recover the catalog and then perform the recoveries. Obviously, it requires more time and burden to start recoveries. This is lower cost. Option two is keep catalog from on-premises in sync with our backup software running in an EC2 instance. So since the catalog is always in sync, your recoveries will start faster. But then there is a relatively higher cost because of maintaining an EC2 instance in AWS. So our customers I've seen some customers prefer option one, some customers prefer option two. So keep this in the back of your mind. Ask your backup vendor what's the most optimal way to make sure that the backup catalog is available in AWS for recoveries. All right, I'm going to walk through some use cases. I have gathered these use cases based on many customer conversations. And the first one is replacing tapes for long-term data retention. So there are three possible architectures. You can actually configure your backup software to, instead of writing to tapes, it can actually dedupe the backups. Typically, they can almost dedupe by 90% or 95%, depending on your data, and compress it so that your WAN bandwidth costs are low and your storage costs are low. So they can dedupe and compress, store it in S3, and then some of the backup products also have the capability to actually read the backup images on a monthly basis from S3 and store it in either Glacier or Deep Archive. So talk to your backup vendor if this architecture is possible where the backups are stored in S3. Everybody does this, but some vendors have the sophisticated capability to read the backup images on a monthly basis from S3 and put it in Glacier or Deep Archive. The second architecture is the daily backups are returned to Amazon S3 and the monthly backups are returned to Amazon S3, Glacier, or Deep Archive. The end result in both these architectures is same. The difference is that this second approach might need a little bit higher bandwidth cost because once a month, you're going to dedupe the backup and send it directly to Glacier or Deep Archive, right? So, and the third approach is Amazon actually offers an AWS tape gateway. So you can replace your physical tape library with this virtual tape library, and your backup software can continue to write to the tapes if you prefer that approach. If we will compress the data, store it in S3, and when your backup software exports the tape, in the background, AWS will automatically export the data from S3 to Glacier or Deep Archive, depending on your setting. A lot of customers actually love this approach because it's pretty simple, but understand that the downside of this approach is that you might require a little bit higher bandwidth cost because the data is compressed and not deduped. So there are pros and cons in each approach, as you can see. Okay. The next one is how do you handle terabytes and petabytes of network attached storage from in a backup context, right? So the first example is you have a backup software, you have NAS, you have been using NDMP backups to physical tape library. What you can do is you can replace the physical tape library with a tape gateway, which is a virtual tape library. And as I mentioned previously, the virtual tape library will write to S3, and when the NAS ejects a tape, we will export the tape to Glacier or Deep Archive. So you can totally eliminate the physical tape library, vaulting costs of tapes, and the operational burden associated with it. The second approach is that from the NAS filers, and some backup products support this, from the NAS filers, you actually mount the network shares into some proxy servers, and the backup product will then back up from the proxy servers, dedupe it, and then send it to S3, and then send it to Glacier or Deep Archive. Both approaches are fine. Different customers prefer different architectures. So keep this in the back of your mind, that if you have terabytes and petabytes of network attached storage, it's a very simple approach with your existing backup software to pick one of these two approaches and send the data to S3 or Glacier Deep Archive. The next use case is about, a lot of customers still have that expensive deduplication physical appliance in their second data center. So how do you, eliminate that hardware refresh cost, which tends to be very expensive, and replace it with AWS? So here are the three choices. The first choice is actually configure your backup software to stop writing to that physical dedupe appliance at the remote site. Instead, your backup software can dedupe, compress, and directly write to S3, and then destage it to Glacier or Deep Archive, or it can write incremental backups to S3 and monthly backups to Glacier or Deep Archive. We covered this previously as well, right? So this is the first approach. Second approach is, let's assume that you have some licenses for yet another 3 years, but you need to exit the data center. Licenses for the dedupe appliance, but you need to exit the data center. Talk to your dedupe appliance vendor. They may have a virtual edition available in AWS Marketplace. So that way you can leverage your existing license cost by spinning up a virtual machine appliance, which includes that deduplication software. If that's the case, you almost treat this as a second data center, right? So all you have to do is configure your backup software and the dedupe appliance to replicate the backups to this dedupe appliance running in AWS. Typically, such dedupe appliances would store the dedupe metadata in elastic block storage and the actual dedupe data in S3. I'm mentioning this because you need to understand that beyond this virtual appliance, there is a cost associated to store the dedupe metadata in elastic block storage and, of course, S3. And the last approach, and some dedupe appliances actually support this, talk to your vendor. They might have actually a tiering capability wherein older dedupe data in their appliance can be tiered to S3 and then to Glacier or Deep Archive. Some support this, some do not. So I wanted to lay down these three different architectures so that you can talk to your deduplication appliance vendor and see how they can get the data, how you can get the data into S3 or Glacier Deep Archive. And the last one use case is handling storage snapshots. Many of our customers love their storage arrays in their data centers. They love their storage snapshot capability because this gives a really fast recovery mechanism in their data centers. They want to extend this capability into AWS. So how do you do that? So some of the storage vendors actually have come up with their technology that can run in AWS. So essentially, you would run your preferred storage vendor in AWS in an EC2 instance typically, and then the snapshots get compressed and trickle down to this storage appliance running in EC2 and store them as snapshots in EBS. And the older blocks can be tiered to S3. So they are optimizing the storage costs, some of these storage vendors. And at the time of recovery, when you want to access the data, you can recover into your private VPC as and then attach from these snapshots to EC2 instances. So pretty neat mechanism from your existing storage array vendor. So please talk to your storage vendor and ask about these capabilities. The second architecture is that their snapshots can be directly offloaded to S3. So this is a lower cost option, but of course recoveries from this will take more time. So depending on what are your requirements, you can pick and choose either of these architectures depending on what your storage arrays support. I know I covered a lot today. That was a lot to digest. Absolutely feel free to have a follow-up conversation, reach out to us and we'll help you out. Just to summarize everything that we discussed today, the hybrid cloud backup architecture lends itself to eliminate your hardware refresh costs in your second data center, eliminate operational burden, because this is you don't have to worry about capacity management and patching. It's more secure because we offer you so many network options and encryption. And if you have time today, we'll definitely dive deep into that. Lower cost, rapid recoveries in AWS. And we went through many use cases today. So talk to your AWS account team if you want to double click on any of the stuff that we discussed today, and also ask them for hands-on immersion days and for any POC assistance. And also talk to your backup vendor for many of the capabilities that I mentioned. Most of them will support most of the use cases that I mentioned. Some of them might not, so it's important for you to understand from your backup vendor. And also ask them about the POC assistance. How can they help you with credits or anything so that you can get started very quickly? We have 4 more such webinars coming up in the next few days. That's all I had today. So let me stop sharing. Alan, let me pause and see if there are any questions or anything we need to cover. Are you on mute, Alan?
Sorry, Chandra was technically challenged getting off of mute there. Sorry, but I just got one of the links pasted. I was busy doing that as Chandra was wrapping up. I will get the other ones pasted in here as well as we chat. For questions, there were 2 that came through that we've had a little bit of a response from myself. But to both of them, I think there's going to be some follow-up. So Ed did ask about customer key management, and specifically related to IBM Spectrum Protect. So I did share details around how we can support that from the S3 side, but I think I need to dive deep into some of the IBM options on that. So that might be a little bit of homework. So Ed, if you don't mind sharing your email in the chat, I can definitely use that to follow up with. If not, I can share my email and you can reach out to me. So either way, I think I'll do that either way. Put my email address in here. But I want to make sure that is good for Ed. And then there was something from Mohammed, which was a question related to the time frame to convert an example, I'm assuming 1 terabyte VMDK into an AMI. And that's definitely dependent on some variables, including what type of instant type are we using, and if there's a warm or cold instance, maybe as a baseline applying just changes versus actually going into doing a complete conversion at failover. So there's some of our vendors third-party vendors that definitely help us with that type of scenario. So I was looking to see if we actually had some baselines to share, which I was not able to find on sort of.
I can add some color to that question. So there are 2 approaches when it comes to recovering. So to answer to your question about the 1 terabyte VMDK, if the backups are stored in this format, which is basically in S3, it needs to be deduped and then it has to be rehydrated. It's going to take time depending on how fast can you recover. However, I think the question is more meant maybe in this scenario where how do you recover rapidly? So if your backup software has the capability to read the incremental change blocks from S3 and store them as native EBS snapshots, eventually when you recover, it takes minutes because you're not converting anything. It's all done for you, right? So that's the beauty of that integrations that some of the backup products have done with AWS. So as long as your backup vendor has the capability to store them as native EBS snapshots, the recoveries will be absolutely fast. Doesn't matter whether it's a 1 terabyte volume or a 5 terabyte volume or a 100 gig volume, the recovery will be in minutes. What it does is after this EBS snapshot is mounted, it will actually rehydrate the blocks in the background. So to your application, it will seem as if the recovery is done, but we actually restore the data in the background automatically into an EBS volume. And if any of your application actually tries to access the data, it would go asynchronously and fetch the data from the snapshot and give it a priority. So that's how the recoveries work if the backup product has stored it as an EBS snapshot. Hope that makes sense. Alan, any other question? Or should we cover the networking aspects?
Chandra, I'll just add on to my typed in answer talked about our cold or a warm instance, and that was the what you're referring to on is it already in an EC2 format. So I just wanted to sort of connect the dots on my typed comment to what you just said. And I don't see any other additional questions, so I'm just scrolling up and down here to make sure. And Ed, thank you for your email. I will use that to follow up with you. And Mohammed, hopefully that has helped answer your question.
Awesome, great.
Thank you.
We ran out of time, and
one last question here was about the shareable. I think we are recording this to have that shared out, so that would be accessible through the registration page.
Yep, and we'll also send the PDF to you, so that should not be a problem. Okay. I know we are at the top of the hour. I can go further and talk through the networking options if you want me to, but so let me know. Just put a +1 in the chat window if you want me to share the networking architectures. Otherwise, we can.
Right. This is Adil. If you can do that now, or you can share also something later on. It's definitely a concern. Yeah.
Okay, yeah.
Mohammed is also a +1 on that, so there does seem to be interest in that, Chandra.
Sure thing. Yeah, let's go through this. Let's go through them. I'd love to, because as I said, networking is extremely security is #1 priority here at AWS. So, all right. So remember the talk about public internet, sending backups from your data center to AWS over public internet, and the second option was dedicated network. So there are actually multiple permutations and combinations within each. So we're going to talk about public internet first. So when do you use public internet? Just a few gigabytes or terabytes of deduped and compressed backups per day, right? So that's the first thing to keep in mind. Remote office branch offices. If you have lots and lots of remote office branch offices, this might be ideal. And then, of course, make sure that you are always turning on encryption in transit using your backup software. So those are the three. Sorry.
Okay. I think there was some chatter, so I did mute. So I think we should be good to go now.
All right. Thank you. Thanks, Alan. All right. So let's look at a little bit deeper, right? So this is your production data center. The backup software continues to write on premises and then sends the data to S3. This is the public internet we're talking about. Make sure that you turn on the encryption in backup software. That's important. The advantage of this is the lowest cost of all the options that I'm going to share in the next few minutes. Encryption in transit using backup software, and of course, encryption at rest. If you turn on the encryption and backup software, it's already encrypted, it stays encrypted. In addition, you can also turn on encryption at Amazon AWS layer, right? So the disadvantages of this approach is it's limited to a few terabytes per day. Because the moment you're talking about tens of terabytes per day, public internet will not scale because you will have latency issues, you will not get consistent throughputs, and your replication windows will fall behind, right? So for that reason, we'll talk about the dedicated network in a minute. But some customers prefer to use virtual private VPNs, virtual private network, on top of the public internet, which is perfectly fine. So that's what I'm trying to show here. So you have your, the gateway in your data center, and then in AWS VPC, there is a virtual private gateway. You set up a VPN between them. So that way, over the WAN, all the data is encrypted, right? Even though the backup software can encrypt the data, as a corporate policy, they have to use VPN. So for those customers, this is perfect. Use the VPN, send the data. So remember, now I'm also showing some costs here. So I want you to be aware of various costs because of this networking choice. So this is when you use virtual private gateway to terminate the VPN, there is a cost of 0.05 per connection per hour, which is not a lot, but want to make sure you are aware of that cost. And once the data lands into this virtual private gateway, the data can go to Amazon S3. There are two choices, actually. Data can go to, since Amazon S3 is a public service, right? The data, it can map to a public IP address. So, of course, the data always goes through the AWS backbone. However, just keep in mind that after this encryption, you have a choice of sending the data to S3 using a public IP address. For many customers, that is just fine because the data is traversing through the AWS backbone. It's fine. However, some corporate policies do not allow to use public IP addresses. For those corporations, you can then have to provision an interface endpoint for S3 in your VPC. So the data goes from here to the endpoint, and then it traverses the private link, S3 private link, into S3. So there are some additional costs. As you can see, our interface point for S3 is 1 cent per availability zone per hour. And again, the private link is $10 per TIB, terabyte, that traverses this network. So what we covered so far is public internet with no VPN, and this is a public internet with VPN. And again, you have two choices. You can directly write to S3 with, or you can go via the private interface here. So those are the options with public internet. The advantages is it's fairly simple, right? It's inexpensive. Encryption is in transit. You can, by the way, you can still turn on the encryption and backup software if you would like. In addition to the fact that VPN is encrypting, and you can turn on the encryption at AWS S3 as well. Okay. The disadvantage of this approach is each VPN link is limited to 1.25 gigabits per second. If you want more than that, you will have to use a different architecture, which I'm going to cover in a second. Chances are very high that you will also need a dedicated network. So let's talk about the dedicated network. When do you want to use this? When you have tens of terabytes. I'm talking about after deduplication and compression. When you have tens of terabytes per day to be replicated from your data center to AWS, you need low latency and predictable throughput, and you need a dedicated network connection. So in this situation, the architecture looks something like this. From your gateway to a direct connect location, right? And this is your router. You have your dedicated network from whoever your preferred choice of internet service provider. So this is your part. And then what happens is at the direct connect location, by using AWS Direct Connect, we create a link between your router and the AWS router, right? So that's the first step. So this is what is a dedicated network. And then what we do is from here that we create what we call as a public virtual interface. Once you create the public virtual interface, the data can be returned to AWS S3. So your backup software can then write to AWS S3, and it uses the AWS backbone, right? But as I said previously, when you use the public virtual interface, even though the data traverses the AWS backbone, it resolves to a public IP address when you're writing to S3. And some corporate policies do not allow that. And if you're one of them, then we'll talk about the private virtual interface in the next slide. Okay. So the advantage of this is, relatively lower cost, not as inexpensive as a public network, but as compared to some other architectures that I'm going to cover in a few slides, still relatively lower cost. It's a secure, dedicated network. It's low latency because of this, and you get predictable throughput. The disadvantage of this approach, as I mentioned, is it uses the public IP address, and there is no VPN. So if your corporation has a policy that you got to use VPN, then this architecture does not have VPN. And of course, it relies on just the backup software encryption here. If this is not acceptable to you, then we will talk about the next slide, which is a dedicated network. Everything remains the same here. Nothing changes. Your ISP dedicated network, and this is a direct connect location. Here, you will create a private virtual interface. What this private virtual interface allows you to do is that when the backup software writes to S3, it does not communicate with the public IP address. It will communicate with a private IP address, right? So how does it work? Your private WIF is attached to a direct connect gateway, and then that sends the data to virtual private gateway, and then it sends the data to interface endpoint or private link to S3. So this is the architecture if you want to use private virtual interface. And I want to highlight two costs here. As you can see here, there is an interface endpoint for S3, which is 1 cent per AZ per hour, and AWS private link, which is obviously $10 per terabyte. If you want to avoid this cost, then go back to the previous architecture where you use the public virtual interface. Let me go back. Where you use the public virtual interface, and it's okay for your organization to write to a public IP address. Remember, your data is secure. It's just that it uses public IP address to write to S3. If that's not acceptable, as I just explained, use a private virtual interface, and then you will incur these costs. I mean, this 1 cent per AZ per hour doesn't add too much, but AWS private link, depending on how many terabytes, this will add up. All right, so this was dedicated network with private virtual interface. Now, what are the pros and cons? This secure dedicated network uses private IP to write to S3. The disadvantage is relatively higher cost as compared to previous architecture, but there is no VPN, right? If your corporate policy demands that you have to use VPN, then we'll talk about the next architecture, which is everything remains the same. It's a dedicated network, but then on top of that, you also create a VPN tunnel between your gateway all the way to this virtual private gateway. In the previous slide, there was no cost for this virtual private gateway because you were not using VPN. However, if you use VPN, then there is a cost of 5 cents per connection per hour. This minor charge, extra charge, but nevertheless, it's a charge. So that's how you have the flexibility to use either a public WIF or a private WIF or a private WIF with VPN. Now, the disadvantage of this approach is that a VPN is limited to 1.25 gigabits per second band throughput. Chances are high that if you have multiple terabytes of data you're writing every day to Amazon S3, you will need higher bandwidth. So what do you do then? That's when we need transit gateway. So that's another piece of technology from AWS that allows you to create multiple VPN connections and increase your bandwidth from your data center into AWS. So here is how it works. This part remains the same. Here, instead of previously you saw that we create a public WIF and a private WIF. Now you create a transit WIF, and you attach the transit WIF to a direct connect gateway and a transit gateway. And as you can see here, there is an additional cost for transit gateway. This does get expensive by leveraging transit gateway. And then, of course, everything else remains the same. Interface endpoint, AWS private link, data gets to S3. The benefit of this approach is it aggregates multiple VPNs to deliver more than 1.25 gigabits per second. So for example, if you need 6 gigabits per second bandwidth between your data center and S3 because of the amount of data that you need to send every night after deduplication and compression, you would probably need 4 such VPN connections, and Transit Gateway will help you get to that point.